Hello, Stats Lab students. It's me, Gary Parker, your math coach. We are going to play around with this week's lab. So for those of you I missed, welcome. On the main course website, I added a new folder called Stats Lab. In there's a brief description of what Stats Lab is all about, and then I will keep posting sections for each lab. So lab 1 is here. There's a printable version, which I have in my Google Docs. This is a modification of the lab in the book. So at the end of each chapter in the book, here's the PDF version of the book. There's a section 1.5 about a data collection experiment. And here they have a data collection experiment for how many movies people have seen recently. Now, people see movies online and in the theater. I hardly ever see movies in the theater anymore. I usually watch them online. Once in a while I'll catch something in the theater. So I was curious about that change in behavior. And so I tweaked this a little bit so that there's 2 questions that I want to try and explore here. And if we look at the second line here, about the movie survey, too far. How many movies, feature-length films, have people seen in the last 30 days versus how many movies have they seen online in the last 30 days? And again, the movies are feature-length films, not episodes of some series you might watch. And online could be something like Hulu or Netflix or Amazon. And this isn't video rentals. That's changed quite a bit recently. That's a whole nother thing to explore. So what I'd like you to do, there's 2 parts to this. I'd like you to try to find a random system, pick some classmates in another class, and ask them these 2 questions. Report back next week with this data. I'd like to get at least 10 people each so that altogether we have more than 60 data sets later to work with. I've already collected some of this data, and so at the end of lab 1 here, I post my data. So here's the data I collected recently about theater versus online. Each row is an individual. So you can see some people saw none in the theater and maybe a few online. 1 in the theater, 10 online. 2 in the theater, none online. So there's a mix of what people saw. 2 versus 30. I still have a hard time believing that 30 movies in a month. 1 a day on average, maybe. Hope it's not a college student. If so, they really need to spend more time studying. Anyway. So this is here for you to take a look at. Each week with the labs, you'll either have a piece of paper to fill out like this and turn in, or you can turn in a spreadsheet. And this lab, you could do either or. And I'm going to show you in a minute what you could do for the spreadsheet. And mostly in the labs, I want to aim toward doing stuff on a spreadsheet because I want to help people improve their skills at using the spreadsheet. Way more useful than using like a TI-83. You get a job later, you ain't going to be using the TI-83. Chances are you're going to be using a spreadsheet to do some kind of math or analysis or whatever. So you're going to need this data right here in this spreadsheet. I have another link to it back here. So most of the stuff I post is going to be in my Open Math. And let's see, here is another link. I mentioned earlier in the course description that there's multiple versions of this book. There's a PDF book, there's an ebook, and there's a web book. This link here is to the web book. And I really like the web book this year. Last year I didn't like it so much because the numbering was a little bit different. They fixed that, and so now the numbering corresponds to the same as in the book. The problem numbering I'm not sure is the same, but we're not doing book homework, so that's irrelevant. So this is similar to the one I showed you in my Google Drive. The difference is here they're only asking about 30 movies, and they want you to collect 60 data points as you're on your own or in a small group. And I've altered that a little bit, so I'm going to get rid of that. So again, I've already collected a bunch of data right here, and I'd like you to find some more. We're going to analyze this data in just a moment. All right. Other things I'll often offer in the lab. I have a weblog, a blog I keep for stat stuff in addition to my Open Math. My Open Math, you have to log in to see stuff. my stats blog anybody can get to and grab stuff. And so I like having things out in the open there. There's a video here of me doing this lab with some other students not too long ago. You should feel free to check that out. I was playing around in that video with some data from the BMCC student enrollment database about class sizes. You should check that out. There's some interesting things there about sampling. Here's the lab that I mentioned, the web view. Here's that same data again. There's two parts to this project. One part is about sampling, the other part is about displaying data. And so most of this video is about sampling, part of it's about displaying data. This spreadsheet here is about sampling. Let's take a quick look at that. Excuse the airplane, I'm doing this outside today. It's such a beautiful day. So suppose you were in a class of 20 people and you wanted to randomly select some of those students. One way to do that would be with a systematic random sample. If you remember, a systematic random sample is where you somehow order things and then you pick every nth item in that group. Here I've set n to be 3, but I've designed this so n could be anything you want. So you can just change this number to something else, like 4. The problem with 4 is that 4 divides 20. So if I scroll through the list, starting at the 14th person, going every 4th, I would go 4, 18, and then I got to scroll back to the list. That would give me 2, 6, 10. Then I'm back at 14, and I'm repeating myself. Now that's all right if I only wanted to select this many people. So I could select 5 people here with a systematic routine cycling back through the list in a specific order, and I would have chosen 5 people at random. That's okay. If you wanted more than 5 by cycling through the class, then going every 4th out of 20 is a problem because then you repeat yourself. So if I wanted a random order of people in a small group, I would want to pick the every other person to be something that doesn't divide into the class size. So 3 doesn't go into 20. So in that case, what I can do is randomly search through the class with a group of people, and I will eventually repeat myself, but not till I've exhausted everybody in the class. Right? If you want to learn more about spreadsheets, I can teach you about these crazy formulas I use here as we go on in the course. Right now, this is a spreadsheet I just put out there for you to play with if you wish. So it's there. So that's one system you could use in your class. Like maybe the way people are seated in class. You could look at the 13th person, then grab the 16th and the 19th, go back, grab the 2nd and the 5th, and you've got 5 people from that class to ask the question to. So we want some kind of randomness in our selection of people. That's important. If we don't have randomness, we could have some accidental bias, and we don't want that. All right, let's go play with the data. That's much more fun. Sampling's fun too, don't get me wrong. But mostly we're going to play with this class is data display and data analysis. So here in the, I guess either one, we could go to my weblog where I list that set of data, or we could go to my Google Sheet where I list that data. Where'd you go? There we go, lab 1. So if something is on a web page, a table of data, or something is on a document, a table of data, generally you can copy that table and paste it into a spreadsheet. I'm just going to use my mouse to highlight the data. You don't want to highlight any more because then the spreadsheet might get confused. So then I'm going to do a little Control-C to copy. I go to my Google Drive, because I prefer to use that over Microsoft Office. And in my drive, I have a Math 243 folder to help me be organized. And in there, I have a lab folder. And so in the lab folder, I'm going to put in a new spreadsheet. And what I'm about to do will work fine in Excel also. Whenever you have a new sheet, whether it's in Drive or Excel, you should give it a name right away. Google makes it pretty easy by just clicking on the title above. I can hit something like Lab 1 Data Display. Call it anything you'd like. And then here I'm going to Control-V to paste. And there's the data. Came in nice. It doesn't always come in nice, so you have to play around with paste options. So you might have to go to paste special and use one of these other options. Excel also has special paste options in the edit menu. All right, so there's my data. Now, just scanning the data, the theater data looks pretty lame. 0, 1, 2, 0, 1, 2, a lot of zeros, ones, and twos. The online data is a little bit more interesting. So I think I'm going to ignore the theater data for now and just analyze the online one. Same procedure I'm going to apply. Could you go to either data set? So what I'd like to do is create a frequency table. Now, when you create a frequency table, you have to have groups or classes. Sometimes they're called bins or buckets. And there's human readable versions and there's computer readable versions. For a human readable version, I might do something like, I'm just going to put human as my title here. Should be better than that. Human readable would be better. All right. I might do something like whoever said they saw 0 or 1 movie, and then 2 or 3 movies, and then 3 or 4 movies. And notice the spreadsheet converted those to dates. Easily fixable. I just re-enter that. If you put an apostrophe first, and you go 2-3, you have, oop, I didn't mean to put an equal sign there. The apostrophe says this is text, not a date, not a number, it's just text. And then it'll display right. So apostrophe 2, 3. Okay, so now it's, oops, apostrophe, what's that? 1, 2, 0, 1, 2, 3, 4, 5, excuse me. So I enter them all in and you keep going. Now there's no, the spreadsheet won't recognize a pattern in human readable things like this. They're generally too complicated. And so I just have to type them by hand. So then I have to type my 6, 7. And dates. Try again, 6, 7, and so on. And you could keep going, 7, 8. And the only way to know where to stop is to have analyzed your data ahead of time to know what the min and the max is. And I haven't done that, so I'm just kind of guessing here. Then there's the computer readable bins. And the computer only wants to know what's the maximum acceptable value for each class. So in this first row, the maximum acceptable value is 1. In the next one, it's 3. In the next one, it's 5. Now that's a clear pattern, right? 1, 3, 5. I start at 1 and I jump by 2. And spreadsheets are really good at recognizing patterns like that. Those are called linear patterns. So I highlight the pattern. Really only need 2, but 3 is fine. And then I can fill it down as far as I want. And it will just keep jumping by 2. Now, this is a small data set, so I can scan it and see the largest number is 30. So I really should extend my data set down until I can deal with that. So let's see, I'm getting closer. All right, so I've got it covered. Whoa, excuse me. All right. My touchpad gets a little sensitive. From there, I want to calculate the frequency. Hopefully you already saw the video I posted on generating frequency tables in Excel or Sheets. I'll repeat that. So the frequency, you need a set of computer readable bins. Again, computer readable bins are each cell contains a single number. Each single number represents the maximum acceptable value for that class. First class, second class, third class, and so on. Then in the frequency column, you highlight each cell you want a frequency to appear in. 1. The +1 is a catch to make sure you didn't miss some larger value, because the way the computer does it is because it's looking at each number in the bin section as the largest acceptable number. That means the first category really accepts anything from 1 below forever. And after the last category is anything above that maximum. Therefore, we catch any possible number, and that's important. We don't want to miss a data element. So then I type equals frequency, and I hope that makes sense. I'll repeat it throughout the course. Hit tab to complete the frequency command. Then I need to select my data. Come back here. I'm going to do the online data, and so I use my mouse. Here I'm using shift arrow keys to select the data. Hit comma. Then I go and find my bins. Use the mouse or click and use the shift arrow keys. Select your bins, close. Now if this were Excel, I would have to hit Control, Shift, and Enter, holding them in that order. order's not that important as long as you get them all about the same time. And Google Sheets, I just hit enter, and it will calculate the frequency for each group. And so here I can see a heck of a lot of people that saw 2 or 3 movies. Few people saw 1 or none. Some people saw 2. One person saw 10 or 11. One person saw 24 or 25. One person saw 30 or 31. No people saw more than 31. And again, the first category is anything 1 or less, or ever less. So I mean, that could be like -1, -2. Now that doesn't make sense in this context, but the computer would detect such things. Frequency. All right. Next, I want to go over relative frequency. And usually between the human readable bins and the frequency column, I could make a histogram. So if I were going to do that here, I would use my mouse to highlight the human readable bins. If I hold down Control and then go over to the next column, I can select disjoint sections. Oops, I messed it up. This touchpad is sometimes tricky. A regular mouse would be much better. Control, click. Try one more time. Oh man. Okay, forget about it. My touchpad is being a little too fussy. Regular mouse would be really helpful right now. I'm on my laptop though. So anyway, if I select these and then I hold Control with a mouse and select these here, I could then create a graph with the human readable bins, which my mother would appreciate. Anyway, relative frequency. Relative frequency is 3 is what percent of the total, 17 is what percent of the total, 2 is what percent of the total. Answer that question, I have to find the total. So way down here, I'm going to add myself a total row, and to find the total on the computer, the formula is sum. And then highlight all the cells above. Close the parentheses, hit enter, and we can see that there were 25 people in this sample. Damn, I gotta get a better touchpad, don't I? All right, so now that I know that, I can go here and say equals. Now, if a number is on the sheet, we should select it. So I click on the 3 instead of typing a 3 in case it changes later. And then I hit divide. And then I want to divide by the total, 25. So I click on the 25. And so it's showing me a preview. That's going to be 12%. Now, the problem is when I copy this formula down, it's going to change the F2 to an F3, then an F4, and so on. And it's going to also want to change the F19 to an F20 and an F21, and so on. I do want the F2 to change because I have a different frequency in each row, but the sum is always located in F19. Now, since I'm copying up and down, it's only the row numbers that are affected. So I put a $sign in front of the 19 to say, don't mess with the 19. Enter. All right, now that I've made this, so again, F2 is a relative cell reference. It changes. F19 is an absolute cell reference. It's fixed. $sign says fix the 19. Click on that formula, point to the bottom right corner, and fill it down. And that will give me the relative frequencies for each row. Now, the relative frequencies have to add up to 100% because that is the data that I have. So I'm just going to check by summing the relative frequency column to make sure it adds up to 100% and that I didn't screw anything up. There's my 100% as a 1. Now, I don't mind these decimals, but my mom would prefer them as percent, so I'm going to highlight that whole column and tell the computer to format them as percents. Okay, so there's my, I don't really need 2 decimal places, so maybe I'll knock that down to 1 or none. It's up to you. I think I usually like 0.1%, so I'm going to go with that one. Next, cumulative relative frequency. So abbreviate that. So cumulative relative frequency means add it up as you go. So what a particular cell means, like the cell I'm in now, means how many items were 3 or less. That 3 or less would be the 17 and the 3. In this column, in this row right here, the third row would be how many numbers are 5 or less. How many people saw 5 or fewer movies? Well, that would be 2 plus 17 plus 3. In a spreadsheet, with a frequency table like this, the way to make that happen is to go equals. And again, this is not cumulative frequency, it's cumulative relative frequency. Now the first item, there's nothing to add up, so I just click on it. In the second one, it's going to be the new percent plus the old cumulative relative frequency. The third one, same idea. It's going to be this new percent to the left plus the old cumulative relative frequency. And this will successively add each new amount to the previous sum. Now, what I could have done is once I wrote that second formula, I could just fill it down. Ooh, something went wrong there. Oh, I forgot to hit plus. So I hit equals, click here, plus, click there. Ah, that's better. Okay, so here I have my cumulative sum. And so I'm going to fill that down. And what I should find is when I get to the last cell with data in it, it should add up to 100%. So right there is my 100%. And so I can see, again, these zeros didn't change the cumulative relative frequency. So this means successively add the new number, add the new number, add the new number, and so on. So that's cumulative relative frequency, and regular frequency. So I'm going to try to use the control enter to do a relative frequency histogram. So I need to know my bins. Now preferably I'd like the human readable bins, but I'm too lazy to type those right now. Hit control and then select this next group. Okay, touchpad, you can do this. And I did it. All right, so I use control to select two disjoints. Remember, you only use control after the first selection. So select normal, then control to get any other unconnected sections. Then I want to insert a chart. And this works pretty similar in, let me reduce the size, in Excel, although the chart wizard is slightly different. So it is trying to graph the bins along with the data. Interesting. So let's go to chart types and tell it that column E is my labels. And it still is not displaying correctly. So what did I do wrong? Interesting. Clearly I did something wrong, so we are going to cancel and reselect the data. Huh, that should have worked. Let's try one more time. So we highlight the bins, control, and highlight frequencies. Insert a chart or hit the magic chart button. And it still is not wanting to behave. Fascinating. I guess I need to get a real mouse and see if it behaves different. Alright, well, hang on a sec. Alright, real mouse. Let's see if it will work. Insert chart. However, when technology does not behave, this is still not behaving. Let's see if I can control it under customization. Horizontal axis, vertical axis, computer bins, that's correct. Horizontal axis, it's not finding that. Oh wait, no, the computer bins is not the vertical axis. Okay, it is definitely confused by something I selected. So it says here to grab E1 through E17 and G1 through G17. That's what I selected. Huh. Strange. Okay, let's forget about relative frequency and try frequency. Let's see if it behaves here. Oh, this one is behaving. Chart types, use column E as labels, and then I get my histogram. And we don't need a legend, so let's go turn that off. And insert it. So the relative frequency will look exactly the same as this. The scale will be different because we're going to have percentages instead. For some reason, my computer freaked out about that. Fascinating. Let's try that one more time. Impedance, control, relative frequency. Chart. Still does not like it. Let's see, it's ignoring some of my data. Apparently it's ignoring column G. Well, I'll have to get back to you as to why this is screwing up. Oh well, sometimes things just don't work right. All right, so so this right here is actually the second part of the lab. So if we look back at the lab, it said first create bins that are just 0, just 1, just 2, and then second create bins that are 0 to 1, 2 to 3, 4 to 5. Now here it says 6, 7 plus. I chose not to do that because I had quite a bit of data that was more than 7, and so it made me uncomfortable to have one class that was much wider than the rest. Usually that's a no-no on a spreadsheet, but sometimes it happens. So I chose not to follow that, and I chose more. Let's do this other version just for fun. So I'm going to come down here and repeat the process. So I'm going to skip the human readable bins because I'm too lazy to type it. I'm just going to do the frequency for computer bins. So here I'm just going to say my bins are 0, 1, 2, 3, 4. And again, you don't have to type all those numbers. If they're each the same distance apart, you can fill down as far as you want. And let's say I'm going to go up through 12. And then the computer will just lump everything greater than 12 into one section, and that'll be good enough. For frequency, you always highlight all the places you want a frequency to appear, +1. And type equals frequency. Spell it right. Tab to complete it. Highlight your data. Comma. Highlight your bins. Close parentheses. In Excel, you will hit Control-Shift-Enter. In Google Sheets, you will just hit Enter. And then here is your frequency distribution. Relative frequency. We need to know a sum first. So I'm just going to put a little category here for more. And then I'm going to go equals my sum. And the auto sum button works fine for this too in both programs. Close parentheses, enter. No, not cumulative, but just relative frequency. Relative frequency equals frequency divided by the sum. Since we're filling this down, we have to say the sum is always in row 41 by putting a dollar sign in front of it. And then fill it down. And then at the end of the frequency column, the relative frequency column, I want to do a sum to make sure it adds up to 100%. Otherwise, I screw things up. 100%. Format these as percents if you like, or leave them as decimals. I'll do percents to one place, one decimal place that is. Cumulative relative frequency. For that, there's nothing to add below the first one, so I just go equals the relative frequency. For the next row, it's the new relative frequency plus the old cumulative frequency. That sum formula gets filled down so that the last cell with data in it will give you 100%. That's cumulative relative frequency. All right, let's try one more of this separated control relative frequency. Let's see if it'll behave this time. Otherwise, there's just some weird thing going on with my electromagnetic field today. Damn, it's still failing to do so. I'll get back to you on why that's failing. So expect in a day or two a response to why this didn't work, because it really should work. All right, that's it for now. As far as the lab goes, what I'd like you to do is use the data I have here to repeat what I just did, creating these tables for each set of classes. So that I want you to get to me as soon as possible. So if you do it in Google Sheets, you can share it with me. My address is math.coach@gmail.com, and that will give me a link to your sheet. Now, this is different than sending an attachment, because what I get is the live sheet. So whatever state the sheet is. So for example, I go send this to Math Coach Parker. Right? He gets an email that says, hey, somebody just shared this sheet with you. I'm sharing this sheet in front of me right here. Oops, I shared the wrong thing. That's okay. If I happen to change this between now and whenever Parker clicks on that link, he'll see those changes. He's going to see whatever current state this document is in. So if right now I deleted this document and he clicked that link, he will get a message that said, sorry, the user threw this document in the trash. So this is different than sending somebody an attachment. They're getting a view of the document in its current state in your drive. If you did it in Excel, you'll have to attach it and send it to me. Then I get a copy of your file. Different than sharing. Takes some getting used to. Let me know if you have any trouble with that. All right, that's it. Oh no, let's see, one more thing to mention. Yes. These questions here we will address at the next lab. So think about them, collect some more data, and we'll finish this up next time, next Friday. All right, take care. Get in touch if you have any questions. That's it for today. Ta-ta. I can figure out how to exit. There it goes.